Let me start. You got 3 minutes fast. I have to go fast. Can you hear me? You may be mute here. Yeah.
Hello.
I know this one. The speaker is coming up here. Okay. Hello, everyone, and then on-site and online attendees. Thank you for coming to our workshop. This is the workshop for future of construction and then build faster, better, safer together with the robot. You can see the more detailed program in that list, that website, construction-robot.github.io. Let me briefly introduce our organizing team members. The Professor Chen, you can stand. Professor Chen here from Mississippi State University, and then Professor Fang here from NYU, and then Dr. Zhang from Baidu Research, and then Professor Zhang from North Dakota State University. My name is Yong Jo. I'm civil engineering and environmental engineering at Georgia Tech. I'd like to briefly talk about statistics of construction and opportunities and challenges at this opening remark. I only very short remark today, so let me briefly talk about it. So construction is overall construction in the United States valued at $1.59 trillion. At the value is value, and then over $10 trillion. I'm sorry, 1.59 trillion US and over 10.7 trillion in worldwide construction market. And then construction sector account for 4.2% of the US GDP, also over 11% worldwide. There are over 36,000 general contractors. We're not talking about subcontractor supply, just general contractor, 36,000 general contractors in US, and then over 10 million construction workers in US. So this is a big industry, but although construction sector has a big impact on world economy, if we, as you know, productivity-wise is stagnating. So compared to other industry, you can see that those yellow, the orange line, there is only 1% annual improvement of productivity over the past 20 years. So we know we have a problem of productivity. Also, in terms of safety, let's look at what's going on. I try to be silent so you guys can see. So every day there are 4 or 5 people die in working day. Okay, working day. Also construction itself has a 20%. Is account for 20% of overall death. So let's say that 2019 there are 5,500 people died. Over 5,500 people died in construction. 55,000 people. 5,500 people died. So construction 1,100 people died. So it's about over 20% of total workplace deaths in US. This number indicating every day. And then what other challenges? So we know there's a strong need for automating and automatizing many construction tasks because of safety issues, productivity issues. However, as you know, construction site is unstructured, but that's not only unstructured. Keep changing working environment, not only main structure, but their temporary structure, construction equipment, people, machine, they are moving around every hour, every minute. So this is a challenge. We can apply our robotics, our automation in construction area. This is our lab actually doing this task in the construction site. This is, you can see the soil condition is a very typical construction site. As you can see, the wheels spinning, you know, the deep penetration of the tire. I mean, it is a challenging environment, but it's very typical construction site. Also, those materials or dirt pile over there, you can see the black dirt pile. They are moving around every 30 minutes. So 1 hour ago site is no longer same site. So it's not a daily changing. Construction site is different every day, but every hour is different. So it is a very challenging construction robot adapt to this ever-changing working environment. and then make an efficient function out of it. It's a very challenging work environment than compared to any other industry. Then we have a situation. So such a typical complex work environment, which method would be better? We're gonna use a teleoperation or semi-automation versus full automation. So left-hand side is the one. Anyway, both cases, well, operator is not in the cabin. So one is, you can see the gentleman standing next to it there, here, right? So he's teleoperating excavator. Also, it can be done at home as well, or through the network. So he can operate this machine from his office as well. That is more teleoperation or semi-automated function there. Versus the right-hand side is full automation. So what approach would be more feasible in construction? Both technologies are very advanced, but we need to think about the real world situation. So this is an open question actually, and then we have a very good debate section later with a similar topic. We can discuss, which method might be better. Let me give you another data. So by 2057, robot could replace or displace 2.7 million jobs in construction. So that's a question. Is it good or bad, right? Is there any resistance from the construction workers because of the fear of losing their jobs? Or we can think about this is a good opportunity for future workforce to get a new skill set to prepare for future technologies. So also this is open question too. So we don't know the answer yet. So today's workshop may be a good opportunity. We can discuss this kind of situation. And then I think we can prepare for future workforce. Okay, so that was my short opening remark. And then we have about 6 invited speakers who are leading experts in field robotics from mix of academia and industry. So let me introduce our first speaker. First speaker here. Great, yeah, thank you. Professor Dinesh Manoza from University of Maryland. Professor Manoza is currently the Paul Chrisman ERB Chair of Computer Science and then Electrical and Computer Engineering at the University of Maryland. He co-lead a major research group with more than 20 members on geometric and simulation algorithm with applications to computer graphics, robotics, and then virtual environment. His recent research include investigation of terrain mapping, multimodal perception, and then hierarchical task and motion planning for autonomous excavator navigation in unstructured environment. Please welcome our first speaker, Professor Manoza.